Hey, everybody. Thanks for joining us again for another episode here of the Amazing Podcast. We hope you're enjoying these conversations because we really enjoy bringing them to you. Because, every week we get to talk to such innovative organizations in this space. It just blows our mind how much is happening out there. And, today as well, I'm really excited about the guest we have, the company we have. I'm Twain Taylor, editor at amazic.com. And if you haven't checked out our website yet, definitely go there, amazic.com. We've got a whole lot of tech interviews like this. We have event coverage, we have tech articles, we have even job listings. So there's a lot that you'll find interesting over there. So head over to amazic.com. And today I have with me Matt Butcher, who is the CEO at Fermyon Technologies. Matt, I hope I got the company's name right. Fermyon.
Yep.
Is that right? Is that how you pronounce it?
Absolutely.
All right. Cool. It's great to have you with us. And I want to get our conversation started with just getting to know a bit about you. So if you could tell us a bit about your background and how you got to Fermyon, we'd love to hear that.
I really kind of got started in the late 90s when I was in high school. I've kind of accidentally stumbled into a software development job and really enjoyed it. And this is, the web was a new and shiny thing at the time, and Java and JavaScript were new and shiny languages at the time. And I kind of found a niche in the content management system space and did a lot of work in OpenCMS, WordPress, Drupal, and thought that was kind of going to be the shape of my career. But I ended up taking a job at HP Cloud right when HP was first wading into the cloud space. And the job was to do the content management system for the developer documentation. But as I got a taste of what cloud had to offer, and I was working on OpenStack, which at the time was just progressing by leaps and bounds every couple of months, I thought this is going to be the next thing. I've got to be deeply involved in this, and kind of made a pivot in my career into the cloud space. Ended up moving on from HP to a IoT company running their cloud. Ended up from there in Google. Left Google after a while and went, I'm going to do a startup thing again. Went back to this company called Deus that was doing a platform as a service based on containers, which were at that moment kind of the new shiny post VM, post OpenStack thing. And ended up making my way into the Kubernetes ecosystem. Wrote the package manager called Helm. And then ended up, Microsoft acquired our little startup in Boulder, and I spent about 5 years at Microsoft. Again, still kind of looking for what's that next thing in cloud. This is such an exciting space. And eventually found the thing that I believe is the new exciting thing in cloud, and started Fermyon just about almost 2 years ago. So
Okay.
it has been a wild ride and a lot of fun.
Yeah, wow, awesome. That's quite a story. You packed in a lot there. I love that.
It was like the quick resume version there, but I mean, it's the theme,
yeah.
this kind of cloud thing. We've gone from these early days where it was hard to even imagine the idea that you could rent somebody else's machine and run your own operating system on it, in the early VM days, onto, that evolution into the container world, and then the rise of sort of like the orchestrator with Kubernetes kind of coming out of that on top. And then, for me, what really intrigued me was this movement into the idea of serverless. But I wasn't quite, happy with what I got. And that kind of opened up this challenge. Is there a better way to do serverless than the way that it has been done in sort of like that first generation?
Really interesting. You've spoken about how you work with OpenStack, and then worked on a container platform, Deus. Now you're doing serverless. So so much you witnessed so much change in the tech landscape just across the past couple of a decade especially. What would you say is one of the things that you have, one thing that you observed or a learning you had as you witness all of this change? Because probably at some point in the past you believed that this is the way forward. Like you're talking about CMSs, initially that was what you thought was going to be huge. And then I remember back about a decade ago when everyone was so excited about OpenStack and how that is the way forward. It's open, it's scalable. And then along came containers and Kubernetes, and then there was a whole shift. And then in between, there's this serverless idea that's somehow making its way and finding its space, finding its little space in this whole landscape. With so much change, right? What do you notice? What are your observations about technology and how it changes? How can you find some sanity through all of this?
That last question really is sort of the question, right? I think anymore it has become clear to all of us that that if you're going into a technology field, you really have to be in love with change, right? And that comes in two different flavors, right? The first one is self-education is just a thing that you have to do, right? Because there's always something new that you're going to have to learn, and the faster and better you can learn it. And the second one is really starting to take a higher level view of how things function together and say, what is the big system I'm building? Not so much what are the details of each technology. To me, the rise of cloud, the story behind the story in the way that cloud has unfolded is that we have seen distributed computing. That's the big thing, right? Lurking just behind the scenes of all these terms like, platform as a service or container orchestration, or all of this is the bigger idea that is distributed computing. And when I was in school, again, back in the 90s and very early 2000s, distributed computing was, in fact, a highly theoretical subject, right? It was not the kind of thing you took your CS 101 class. I worked for Brendan Burns, who is the creator of Kubernetes. I worked for Brendan Burns at Microsoft, and he used to say pretty regularly, our goal is to take distributed computing from the CS 400 class and turn it into a CS 100 level class. And that really sort of stuck with me, that is in fact the story we're seeing as cloud unfolds, is that virtual machines made it possible for us to start putting compute out there outside of our data centers and abstract away. Then containers gave us a much more efficient way of packaging that. And then Kubernetes comes along and the other orchestrators, Nomad and others like that. And they showed us a way, along with the microservice design pattern, to run all of these things out there in concert so that we could kind of make use of the compute resources available. But they're all still in the data center. Serverless came along and then promised, hey, we can do a better job of making the basic building block very simple. So now you're thinking of writing an event style system where you take a request, you handle it, you return a response, and you shut down. No more are we sort of saddled with the 1970s style, set up a socket server, listen on a socket, configure your TLS certificates. And so each of these is sort of like adding a little chunk to that overall recharacterization of distributed computing from being a highly academic, very, very tedious kind of system into the kind of thing where every developer can write a piece of or a giant application in a distributed computing style. At least that's what I hold on to keep me sane, right? That's got to be what we're building. We're building something bigger, right? We're not just reinventing the same pieces over and over again.
Yeah, no, I think you really grounded it into something much larger than just the surface or the output or what it looks like on the outside. So I think you really give us something to hold on to as we talk about these different concepts. But I want to also get from you your view or your definition of what we're going to be talking about for the rest of this podcast, which is serverless. How would you define serverless computing for someone who is not probably heard the term, but not really done much study about it, just interested and curious? How would you explain it to them?
Yeah, I think there are, and serverless like cloud is one of those words that was put out there and then the meaning was fairly obscure and it turned out to be confusing. But to me, the core question is, okay, so if we're serverless, what's the thing we're doing without, right? And I think for me, I like to just frame it out in terms of the software we're writing, right? We used to need to set up a server, write a server, right? Set up the socket server that opens on a port and listens for requests and then handles every request. And that's the thing we're doing without, right? In the old way of doing things, we would write these applications that divvied out requests to different handler functions, all written inside of this fairly large application. Over time, we've gone from monolithic to sort of microservices, and serverless, I think, is one narrowing step even from the typical microservice kind of thing, where instead of writing a software server, we're just saying, I am only writing the event handler, right? I'm just writing the thing that takes the request, does some stuff, and returns the response. And I think that's kind of the easiest way. It's not so murky that you start saying, well, there's servers somewhere. Well, yes, there are hardware servers somewhere, and there's a socket listener somewhere, but that is not the developer concern, right? The developer concern is I write a small program that deals with requests, returns, responses.
Really interesting. And it kind of sounds like it's about puts a focus on getting things done and focusing on the actual business problem that you're trying to solve, the application logic rather than just the underlying plumbing and all of that. I think, and that's a good thing to focus on. How have you seen developers and ops folk look at serverless? How are they different in how they look at serverless in terms of the benefits and what attracts them towards serverless?
Yeah, I think with developers, there are two main points that are highly attractive about serverless. The first one you already hit on, right? It gets me straight to the thing I care about right away. I don't have to deal with much boilerplate at all. I'm really just saying, here comes a request. I want to do this thing and I want to return a response. It's all about writing what we usually call the business logic. So that's number one. Number two is, I think, the promise that and maybe to frame this out, let's talk about what Kubernetes looks like for the developer, right? I was very deeply in the Kubernetes ecosystem for many years. And when I wrote Helm, in fact, one of the guiding principles was, how do we make this more approachable for developers? Because developers are being asked to learn a lot about how infrastructure operates. And in the Kubernetes case, even at an abstract level that required all of us to kind of learn new terms like pods and deployments and services and things like that. But what I heard from developers and what we at Microsoft were hearing from developers is, this is too complicated for me. I don't want to have to think about the operational side of things. I want to write my code. I want to focus on writing my code, and I just want to say I need this deployed out somewhere. And serverless seems to be kind of that ideal level of operational considerations that developers feel comfortable with. So I still think there are a lot of things to streamline. And we at Fermyon have spent a lot of time saying, what other speed bumps can we remove from the serverless road? But I think that's the second attractor, right? Is I just focus on writing this piece of code. I push it up somewhere. I don't have to worry really anything at all about what the infrastructure looks like. It's just there and running the way I expect it to. And I think that after the Kubernetes swing, developers really liked that. I think, though, on the flip side, the platform engineers and operations teams have found serverless to be somewhat frustrating, because it doesn't look the same as the rest of the infrastructure. It doesn't follow the same rules as the rest of the infrastructure. And I think consequently, that has led many of them to feel like, I'm constructing a Frankenstein's monster of a system here. I've got all the Kubernetes stuff in bucket A, and then over here on the side, I got the serverless stuff that is harder to manage, and I'm not really sure, what to do with it. So for us, really trying to meet the needs of the developer and the operations team, that's a very important kind of approach that we've wanted to take. And it made sense to really start with the developer story and say, how can we make this whole serverless environment very quick to set up, very easy to do local development, very easy to deploy out into production somewhere. And also then on the operations side, how do we make it so that these same serverless applications, the developer can run it in Fermyon Cloud or one of these kind of managed layers, but how does the operations team take that and say, I want to run this serverless platform inside of Kubernetes or inside of my Nomad cluster and manage it the same way that I manage the rest of my services? And so we've really tried to tell both of those stories.
I like that you also talk about the challenges that the ops side of things, those teams face. It's not just all a rosy picture that you're painting about serverless, and I like that. You also mentioned in passing that when I wrote Helm, you said, so are you one of the creators of Helm? I didn't know that.
Oh, yeah. Yeah, so Helm started as a hackathon project at Deas, not too far south of where I'm sitting at this moment. We were gathered at an all-company meeting, and our hackathon project was, we were just introducing Kubernetes into the ecosystem. and into the company's ecosystem. And so the kind of task was, let's get all the developers kind of started on Kubernetes. I, of course, had a little more experience than many of the other developer teams because I had led a lot of the early investigation into Kubernetes. But my team, we said, okay, what if we were to do something really ambitious? What if we were to try and build a package manager for Kubernetes? And so we spent our 2-day hackathon building the prototype of what later became Helm. We won a $75 Amazon gift card when we came in first place in the hackathon competition. So, that's open source payoff for you right there. No, it also kept me gainfully employed for 7 or 8 years, which I will never complain about.
Wow, amazing. Yeah. Wow. I didn't know that. Are you still involved with the Helm project at all?
Yep. Yeah. I still am the head of the Helm org. I do very, very little coding on Helm these days, but still do a lot of the work on the organizational side of things.
Wow. I'd love to have you back for a part 2 to talk about your journey with Helm.
Oh, sure. Yeah, that'd be fun.
Yeah. But coming back to serverless, you mentioned Fermyon started 2 years back, but then serverless has been around for a while now.
Yeah,
I'm not sure the exact year when
Lambda's about 10 years old. Yeah.
Okay, that's really long time. So it's been around for a while, but it seems like there's something wrong with or something missing in the serverless space as it is, which led you to want to start Fermyon. Could you talk about that? What's missing in serverless right now? As you look at it, things like Lambda and all of the other solutions, what's missing with that?
I think that Amazon's original idea with Lambda was to turn, Lambda into sort of like a utility layer that you could use to kind of orchestrate or script up some actions between different Amazon services. But what happened was that developers really liked that model and began wanting to write frontline web services in this, either microservices with a JSON style REST API or front-end web interfaces or backends for web applications. But the technology that functions as a service has been built on is largely kind of an old technology that was not built for that. It's largely every function as a service, right? Every Lambda function or every serverless function would run on top of a full-fledged VM. And over the years, that's kind of mutated a little bit here and there. But when we were looking at this is kind of the original problem that piqued our interest was we were looking at the runtime profile of a virtual machine, the runtime profile of a container, and saying, okay, so a virtual machine is sort of like a heavyweight, right? You pack up an entire operating system from the kernel and drivers all the way up to your application. And you push that entire big blob onto somebody else's runtime, and then that whole big thing executes. This is fantastic, right? Because it means essentially the sky's the limit. Anything you can run on an operating system, you can package up in a virtual machine and run it somewhere else. That's really cool. But the runtime profile means it's kind of slow to start up. The images are just massive. And so it scratches some itches, but it's not going to scratch all of the itches. So we asked ourselves, what was going on with containers? Well, containers offered a different value prop. And that was, I can package up a single service, right? Especially in the Docker mode of thinking about containers. I package up a single service, a database, an application server, PubSub, whatever. And just that service, it's supporting segment of the file system, and it's supporting libraries, and I ship that off somewhere and run just that. So the images are smaller. And instead of taking minutes to start up, it really takes, seconds to start up, maybe, 30, 40 seconds up to maybe a minute or two, right? And then I've got my entire application running. So we're looking at those two and going, yeah, but don't we also want a kind of cloud runtime that just holds a small application, just particularly like a serverless application, right? An event handler, but that its startup time is milliseconds instead of seconds. It's, file sizes are very, very small. And we can kind of scale them up to 10,000 or 100,000, whatever, and scale them back down to 0 without incurring any kind of runtime penalty for starting and stopping these things repeatedly. So what kind of piqued our interest about this was serverless functions were gaining traction, but the infrastructure behind them was old and kind of rickety and based on virtual machines, which were not optimized for the use case. So really, we were going, okay, we might have an opportunity here to create kind of a third wave of cloud computing that's going to sit alongside of the container ecosystem and the virtual machine ecosystem. We're not trying to solve all the problems. We're just trying to solve this one remaining problem that we could see very clearly. And if we could do that, then suddenly serverless function startup time would go from 200 to 500 milliseconds to under a millisecond, which is where we are now with spin ones. And instead of having to maintain these elaborate queuing systems of pre-queued VMs where workloads get dropped on the last mile and we could execute them, which is a huge waste of compute resources, right? Because you basically have a queue of things sitting idle waiting for Lambda functions to drop onto them. We said, okay, instead of architecting that way, we could take one fairly modestly sized virtual machine and configure a multi-tenant environment where we could run tens of thousands of different user applications on this. And that ultimately was what got us into WebAssembly as an enabling technology, which was, essentially we didn't want to invent a runtime from scratch if there was already a really good one. And we looked at the virtual machine landscape, looked at the container landscape, and then said, so what's the analog? Is there a technology out here that is that kind of fast compute resource that also has a really good security model? And the surprising thing to us as we kind of winnowed the field down was WebAssembly, a technology built for runtime isolation in a web browser, actually had all of the characteristics we wanted for this kind of third kind of cloud environment, a really good security sandboxing model, safe multi-tenancy, cross-architecture, cross-platform compatibility, a wide variety of languages supporting it. And we went, hey, somebody built this already. Let's just kind of pick up this idea and drop it in the cloud and build a serverless runtime based on that.
Wow, really neat. And I want to ask if you could tell us a bit more about WebAssembly, since it's such an important part of Fermyon as well in what you do. And for me as well, I've been hearing WebAssembly a lot, but I don't really have it, in my mind as, this is how it fits into the whole cloud landscape. So if you could, and I'm sure a lot of our viewers and listeners as well have those kind of questions about WebAssembly, how would you explain it to us? What is WebAssembly and where does it fit in the cloud ecosystem?
So the original problem that WebAssembly set out to solve was really a problem that's as old as the modern web browser, right? Early on in browser history, JavaScript was kind of a toy language. And the developers of Netscape and Mosaic, well, mainly Netscape at the time, wanted to support a big programming language. And so Sun partnered with them. They supported Java as the kind of applet format. And the idea was really you could have a compiled language that executed in the browser. Well, we all kind of know that Java found its niche elsewhere, and most modern browsers don't support Java applets at all. And we saw kind of a litany of other technologies kind of come and go, including Silverlight and Flash and things like that. But the team at Mozilla in about 2015 announced a new project that was designed to kind of solve what they thought were the two big problems with the previous attempts to provide multi-language support. The first one was every time it introduced one language environment, right? The JavaScript language or the Java language environment or the .NET language environment. And they said, we want to introduce one that supports any language so a compiler, any compiler can add support for this language and we should be able to run it. And the second one was really this kind of thing of saying, let's do it all open source. Let's do it all under a standards body. Because in that case, we're not fighting the vendor lock-in story that Sun fought, that Microsoft fought, that Adobe fought, right? And so that was the kind of genesis of WebAssembly. Mozilla quickly got the Chrome team, the Apple Safari team, the Microsoft IE at the time, then Edge team, all on board with this. Those companies all worked together under the auspices of W3 and produced this really cool language-independent bytecode format and runtime. So when you think about the profile you're shooting for in a web browser, right? Well, the first thing is, if you're running somebody else's code, and you don't trust it, you want a really good security sandbox. So WebAssembly was built with a very good security sandbox environment. The second one is you cannot return to the user, oh, this only runs on Intel or this only runs on Windows. So it has to be cross-language and cross-platform. The third one is we as web browser users are notoriously impatient. And so the startup time has to be really fast and we've got to see something happening right away. And then kind of the last one is that they really wanted to target this language neutrality thing. So they said, all right, we're going to start with C. And then they ended up starting with C and Rust, but two fairly different programming languages, and try and build a bytecode format that both of those languages could compile to, and think about the way that scripting languages and bytecode languages like Java and .NET, think about how those would interact with the system and basically entice compiler developers into building backends that compile to WebAssembly. So that was kind of the in-browser story. And you saw some big successes like Figma, for example, uses C++, writes C++ code, compiles it to WebAssembly, runs it in the browser, and JavaScript can then access the C++ libraries. For us, we looked at that checklist, right? Security, speed, cross-platform, cross-language, and said, that is exactly what you want on a cloud runtime. You want all those same characteristics. This is a perfect match for us. And so we took that same kind of runtime and implemented one on the cloud side for the same reasons, right? And essentially, for us, the problem we were solving was we want to make serverless functions where we can run very efficiently, tens of thousands of them, even multi-tenant ones, in a secure environment where the developer really doesn't have to know anything about the server. They can write their code on Windows, on an Intel processor, compile it, and we could run it on Linux on an ARM processor. They would never have to know, right? And so we saw all those strengths in WebAssembly, and they just seemed like a good fit for the kind of serverless environment that we were envisioning. And along the way, I mean, to your point, we're seeing a lot of other places where WebAssembly is gaining traction. So, of course, the browser side of things is still booming. IoT, there are a lot of use cases there. So if you look at, BBC wrote a blog post about how they use WebAssembly for their player. Amazon, I believe, also wrote one about how Amazon Prime Player uses WebAssembly. I believe Disney Plus also uses WebAssembly in their player. So there's an IoT case for that. And then I think you're seeing the plugin models like Shopify allows you to write custom backend chunk data processing chunks and compile them to WebAssembly and run them on the Shopify platform. I think that's another really cool use case for it. So you're definitely seeing WebAssembly prove to be more generic than it was originally anticipated.
That's a fascinating detour. And yeah, just so much to dig into there. Definitely want to go and research more about this. Seems like, we've all been using WebAssembly without even knowing it. And it's really cool, just the kind of use cases that you mentioned. But drawing us back to what we were talking about, which is serverless and getting more into Fermyon. If you could tell us a bit about Fermyon, what's your approach with Fermyon and how does it use WebAssembly? What's Fermyon's take on serverless? You already kind of mentioned this in your previous response, talking about what's missing in serverless today. But if you could extend from there, bring us to Fermyon and its approach. We'd love to hear that.
Yeah, so for us, there were really kind of two big pieces to this. The first one was we wanted to build a development environment that was really friendly, right? How the kind of way we started was how many speed bumps can we remove from the developer's road? We actually ended up in our first year saying, okay, the key user story we want is, as a developer, I can go from blinking cursor to deployed application in 2 minutes or less. Yeah, it's going to be a hello world, but if we can get the mean time to dopamine down to that, then that's a delightful developer experience. So that was chunk one, and chunk two was we really want to make it easy for developers to deploy this app somewhere, but in a way where we can enable platform engineers to kind of begin building their own things based on this too. So on the first side, then we said, okay, what does a developer tool look like? We built a program called Spin. It's open source. Fermyon Spin basically is the developer tool and platform. So you type in Spin new, you create a new application, you build out your application, and you get all the way up to Spin deploy that pushes it up somewhere and deploys it. And then on the flip side, we had the cloud, right? What's the cloud side look like? We originally introduced a reference implementation called Fermyon Platform that showed how to run Fermyon Spin runtime inside of a Nomad environment with console and Vault. We've since also added support for Kubernetes. But all of that is great for a platform engineering team. We needed something, though, to allow the developer to continue to have that kind of streamlined experience. So we released in October of last year Fermyon Cloud, which is basically our hosted version of a Spin runtime, a massively scalable Spin runtime that has built-in data services like key value storage, database, AI inferencing, configuration, things like that. So really, to us, it kind of breaks down into these two pieces. Spin for developer to tell the developer story and tell it well, and then the cloud side of things, Fermyon Cloud and Fermyon Platform, to be able to deploy these applications from the developer's workstation to a place that is either entirely managed for the developer or managed by a platform engineering team that can integrate it into their existing Kubernetes environment, say.
All right, and we're going to dig into this a bit more. What's you mentioned, you want to get the mean time to dopamine down
Yeah.
really short. I love that phrase. But what's the number you put out? What do you say, get started in how many minutes or seconds? What's the number you normally talk about when you talk about getting started?
So we started with 2 minutes or less, right? From blinking cursor to deployed application in 2 minutes. We figured 2 minutes. Well, we figured 2 minutes because really the story we wanted to tell was, developers will often hit. This is our mythical developer, right? Hits a Friday afternoon. They're making their way through the to-do list. They've got like an hour or two left at the end of the day, and they're like, I got to fill an hour or two. I'm going to learn something new. That little window of time is our opportunity to show them the value of doing something this way, right? To show them the value of WebAssembly, to show them the value of this kind of serverless computing environment. So we needed to make it super fast for the developer to get going, and we needed to make it as hiccup free as possible, because in that moment, if you hit a hiccup at 40 minutes into your Friday afternoon window, you're going to go, all right, well, I'm going to read TechCrunch for 15 more minutes and then head out the door. So that was why we got to this kind of 2-minute story and said, okay, if we can get them to Hello World in 2 minutes and then give them the tools to try out all kinds of other things, then they will have hit at least one success and gotten that dopamine hit, and then found some other things that they can start doing that hopefully then, our idea is like, that should entice them into a weekend project, which will entice them into introducing it at work and that kind of thing. That was the vision for how we imagined reaching out to developers. That open source story is always key in there too, because we want the developer to be able to look at this and say, oh, I understand how this works. I wish it did this. I can contribute an upstream fix for that. And we've seen that story just really resonate. I think we crossed 100,000 downloads of Spin a couple of 3 or 4 months ago now. So that's only about a year and a half into its lifespan. It already had crossed that kind of download. And I just, to me, that means, okay, something here is resonating with developers, right? They like this particular experience and they like this kind of short time to being able to have something up and running.
Wow, awesome. I'd love if you could show us Fermyon in action itself. If you give us a walkthrough of what Fermyon looks like, what it looks like using Fermyon. I think Spin is the developer interface, right? That you want to show us.
Yeah. So let's give it a shot. So we've got Spin here. So I've already installed it. If you want to kind of see how to install Spin and get it running locally, developer.fermyon.com is where you would go. You can click through to the quick start guide or the install guide if you have something more exotic, but I've already installed it here. So we're really only going to do 4 different commands. We'll do a TypeScript program here. So I'm going to do a Spin new. So Spin new will scaffold out a new program for me. I want to do an HTTP handler. I want it to be running TypeScript. So I'm going to give it the HTTP-TS template. There are a whole bunch. You can run Spin templates list and see all the different languages and all the different protocols that Spin supports, but we'll just go with this one. So we'll name our new program Amazing. And we're going to just accept defaults here and not walk through. If I omit this, then we'd walk through a question answer thing where I could add a description and tell it what my default routes should be. We're just going to let Spin generate a comfortable set of defaults. So now over here, I can see it's scaffolded out a project for me. And that should look like kind of your run-of-the-mill JavaScript, TypeScript kind of environment, right? We've got our package.json, we've got our TS config. We also have a spin.toml file here. And this is really the TOML file that explains to the Spin environment, this is how you work with source that's in TypeScript and eventually convert it to WebAssembly and then run it inside of the Spin runtime. So this is an important file, but one that we're not really going to take much of a look at. And we can see inside of the source directory, we've got our index.ts file. So the first thing we're going to do is npm install to get all of our dependencies installed. But if we take a look at this index.typescript, this is essentially what we're importing. We want this Fermyon Spin SDK. It's going to give us that serverless environment. So we're going to get our HTTP request, our response, our handler, and we're going to basically just implement a single function. Right, so it's a serverless function right here. So here's our TypeScript function. It's named handle request. It takes a request, an HTTP request, and it returns a promise for an HTTP response. Very, very basic, right? When I scaffold things out, it scaffolds out something that I can just immediately build. So I'm going to just go ahead and Spin build this. So what it's doing now is it's going to, fetch, install, configure all the things I need, and then it's going to build it into a WebAssembly module. So again, this is a binary representation of my application that's written in TypeScript. So if you're keeping track at home, that would be TypeScript to JavaScript to WebAssembly, and then we've got a WebAssembly binary there. And then if I want to test it locally, I can just type spin up, and already I'll just do curl here real quick. I can do a curl localhost and see that running right away. So let's go ahead and change our hello world in a sort of trivial way. I don't know. Hello, amazing viewers, and give this a shot here. So all I'm going to do is recompile this. So once more, I'm going to do a spin build, if I can type spin correctly. And then it's built it for me again. And again, I could spin up to run it locally and go back over to my little curl thing. And now I should see my updated output there. Hello, amazing viewers. And now if I wanted to deploy this to Fermyon Cloud, right? So again, the story we want to tell is from blinking cursor all the way to deployed application in 2 minutes or less. So the last part of that would be, well, how do I get this deployed? Well, I'm going to do spin deploy. By default, this is going to push it to Fermyon Cloud, which is our hosted cloud. Again, there are all kinds of different deployment options, including Docker desktop, Kubernetes, Nomad clusters, and so on. But here we'll just go with the easiest and the default. So this is going to deploy it out into our cloud. It's going to return back an auto-generated URL. I could go ahead and customize that URL if I wanted, but I'm just going to go ahead and execute that. And there I can see I just made a round trip up to Fermyon Cloud and back. That application is now deployed. So that's really the kind of experience we wanted to give. I could do the same kind of application very easily in Rust, in Go, in JavaScript, in Python, and other than the particulars of the language, that same sequence of commands minus the npm install would be the same kinds of things. I'd do, for a Go program, I run spin build and it calls out to the TinyGo toolchain and compiles it to WebAssembly. Likewise, for Rust, it calls out to the Cargo toolchain. So the idea was to just streamline as much of that developer experience as we could, removing all the different little roadblocks. From here, the kinds of applications we could build, and I know we're short on time, so I won't go into them. But from here, the kinds of applications we could build, we could use the key value storage to add state. That's the way that we build stateless applications, store something somewhere and can retrieve it very easily without necessarily having to set up and configure our own key value storage like a Redis or something. Similarly, there's a pre-provisioned database if you want to use a SQLite style database, and AI inferencing if you want to use the Llama 2 model and be able to write prompts and have it return back responses. So again, this idea is, in each of these cases, how do we make it easier and easier for you as a developer to write these kinds of serverless functions that are high performance, but also have the kinds of data services you just need to get the job done, right? The typical full stack developer tools.
Yeah, love it. It definitely, cuts down a lot of those manual steps that are needed to really, configure and provision so many different things, before you can actually get to deploying an application or a service.
Yeah.
So it's really fast, really intuitive, really, really seamless.
Yeah, a lot of the really things that were frustrating to me early in my Amazon Lambda and Azure Functions days, years back, that got me thinking this was a problem, was that it took me 47 minutes to do the hello world for Amazon Lambda. And the why wasn't because the code was hard. The code was trivial. The why was because I was spending all this time wiring things up and not understanding entirely what I was doing and having to generate my own SSL certificates. And I just thought, we as developers, we don't have time, patience, or the desire to do any of those things. So if we could just kind of streamline those out, we didn't have to do any proxy configuration to get our default URL mapped. We don't, that's the kind of stuff that just, as a developer, it made me happier. And the kind of the objective as Radu and I and the rest of the Fermyon team built this out was, what do we do to make developers happier with their development experience so they can be more productive, have less maintenance to do, and still, get to use the languages and the platforms that they like.
Yeah. And what's it like for the platform engineer? So do they need to do a lot of setup and configuration to actually enable this within Fermyon before the developer can actually have this kind of seamless experience? What's their onboarding experience like?
So the Fermyon Cloud one that I just showed is our managed one, right? So the one step I had already done ahead of time is I had already logged in, and that just uses a GitHub OAuth. And so it's that's the easiest way for the developer to get going, right? Once we're talking about running it on-prem or in your own cloud, you got a couple choices to make. Do you want to run it in Nomad? Do you want to run it in Kubernetes? Do you want to set up your own kind of environment? And then really you just go out and pick the installer for your particular environment. So we have a repository at github.com/fermyon/installer that'll basically use Terraform to install the entire HashiCorp stack in however you want it configured. We also have a project for a K8s installer that'll install it into Kubernetes and get your vanilla Kubernetes cluster. As long as it uses containerd as its runtime, you can very easily install it there. In fact, if you want to start with AKS, Microsoft AKS already includes support for Spin. So you just turn on the experimental support for Spin and it'll install the containerd shims and all of that for you. And we continue to work with Red Hat to get support for their container runtime, which is based on crun, I believe. So we hope to make it possible for the platform engineer to say, look, this is what we run. We run OpenShift, or we run AKS, or we run EKS. I just want to install it in here. And yes, it's going to be a little more work for the platform engineer because they want to make the decisions about how is this service going to be backed by a storage option, and how are we going to schedule things to go in with, how many nodes are we going to allocate? But it really does keep the platform engineer focused on doing what they want to do, which is describing, installing, and operating the platform. So they're not going to be able to get that installed in 2 minutes or less, but we are still targeting an hour and a half should be about the right time to get this configured in your typical Kubernetes cluster. Again, if you want to do it the fast way, AKS already has all of this stuff built in. And in that case, it's how much time does it take to provision a Kubernetes cluster? But with platform engineers, it's all about giving them the right tools, the right knobs and dials to turn to make this kind of thing operate in the environment the way that they want it to. Once they've gotten there, then it's really easy to kind of set things up for the developer and say, okay, here's your endpoint, point spin at this, and then when you spin deploy, it'll go out here. Or you can even write Helm charts to deploy WebAssembly serverless applications into Kubernetes environment. That, for me, I did not notice that at first, admittedly. So as the creator of Helm, seeing somebody do that the first time is like, oh, wow. I had never envisioned using the tool to do that. So I love experiences like that. I think it's something we as developers enjoy more than anything, right? Is seeing somebody use our tool in a really novel way with great success.
Yeah, I mean, and not too many can actually, have those kind of experiences so many times. And it's great that you get to have those experiences quite often. I think that's really special.
Pretty fun. Yeah.
I want to ask you a bit about, you mentioned Nomad a couple of times and HashiCorp suite. So was there a reason for you kind of having, seems like a lot of support for HashiCorp products, especially Nomad. Was there a reason for that? Could you explain a bit of the background there?
Yeah, so Fermyon Cloud actually does run on the Hashi stack. And the reason for that is because when we were trying to build a really high performance version of this, so what we wanted to build was the average developer or the average platform team probably needs to support hundreds, maybe up to around 1,000 applications in their cluster before they accept the fact that they want to scale it out. For us, we wanted to be able to support a huge number of Fermyon Cloud users, tens of thousands out of the gate, and then going upward from there. But we needed to be able to do it in a way that wasn't going to cost us too much money. As a startup, our budget is a little thin. And so we looked at trying to squeeze a lot of value out of a scheduler. And we found that with Nomad and with our own kind of custom LHC runtime it's a Nomad extension, basically, a Nomad plugin, we could pack 1,000 different applications onto an Amazon-sized 2XL node. So density-wise, your typical Kubernetes 2XL node is going to be able to support around 20 pods. The typical upper bound on Kubernetes is actually in the 200s per 1624XL size images. In order to make this serverless thing really show its value, we needed to have it running thousands of serverless applications in each instance. And Nomad just helped us get that done very, very quickly. So our first version of the Nomad driver, we literally hacked out in a weekend. And it's evolved a little bit, but still it's one of our lowest maintenance pieces. In contrast, the Kubernetes story has taken us, and we partnered with Microsoft and again, Red Hat and many others to kind of build out the Kubernetes support. And it's taken us well over a year to get to that point, and we still aren't quite at the same level of efficiency. The thing is, it's worth it because Kubernetes supports so much other stuff, and so many organizations have bought into Kubernetes that this is still a great story for you, but it was not the story that we found to be the best way for us to execute things in Fermyon Cloud. So that was why we chose Nomad.
Really fascinating backstory there about Nomad. Really interesting. And I want to also you spoke a bit about, packing a lot onto a single instance, and you're talking about thousands of pods running on a single instance. That's mind blowing, that number. And I also kind of seen this reflect on a bit of the, reading through your website now that I see you talk about this thing called sustainable computing. And I think it kind of ties into this concern about costs, and how sometimes costs can quickly spiral out of control with especially the cloud. And you see a lot of people talking about cloud repatriation, FinOps, especially in this economic environment. So,
and
tying all
even
of this together.
Even AI, right? As we've seen AI inferencing take off, the amount of CPU that it uses is very high. The amount of GPU it uses is very high. So we're seeing these same themes that, I think that, so I had this conversation back when I was working at Microsoft. One of the cool things about working there is, like Google too, right? Teams are very open. And so it was frequent that I would talk to other teams, and I had kind of my list of standard questions to break the ice, right? And then I was talking to someone from the Azure Compute team, and I said, as one of my standard icebreakers, so what would you say is your biggest challenge? And I expected some kind of highly sophisticated story that I barely understood, right? Let's be honest, I don't understand the underpinnings of VMs nearly at the level that I probably should. But instead, his answer surprised me. He said, well, the problem is we rack servers as fast as we can. Right. The demand for this service is growing and growing and growing. And we have hundreds of thousands, probably millions at this point of CPUs running. But he said, most of these spend most of their lifetime idle, or at 80%, 20% utilization, 80% idle. And he said, that's because, in Kubernetes, you're always over provisioning. In, Azure Functions, you're always building up these queues. Many applications will answer several thousand requests a day, but then they sit idle the rest of the time. And he said, it's just kind of the nature of things, but how frustrating it is to know that I'm racking as fast as I can go, and still these things are sitting largely idle. And that conversation really got me thinking. That means that, we've got an 80% inefficiency rate on a lot of these systems, maybe the vast majority of these systems. They're burning electricity. That's costing money. That's having an ecological impact. We're frankly, not being good stewards of the resources we have, and we're passing all the cost on to the customers of the cloud. Again, this is me thinking in the Microsoft lens. And that turned into kind of the big challenge for me personally, right? What do we do to cut down idle time? Well, there would be various ways to tackle a problem, but the one that seemed the most salient to me was, can we just figure out a way to pack more workloads onto the same system in a secure kind of way? And again, going back to that, what would the next wave of cloud computing be? That was one of those core problems. We called it the scale to zero problem. How do we make it so that you can scale all the way to zero for any individual tenant up to 10,000 nearly instantly, and at the same time share those resources with other tenants, so that again, we're cutting down on the amount of waste. Now, along come these other technologies, right? AI being the current hot one, and they have the same problem. GPUs are ridiculously expensive, right? Just absolutely. You're talking $30+ per instance hour on Amazon. You're talking tens of thousands of dollars if you want to buy an A100, right? These are it's very expensive compute. So this is a very salient problem again for users. They're going, oh, I don't want to invest $35 per instance hour. How do we cut that down? It just so happened, and this was not our intention when we built it, but it just so happened that by choosing WebAssembly and by choosing to optimize in this kind of serverless time slicey sort of way, multi-tenant time slicing, that we had built the right platform for AI inferencing as well. because really all we needed to do was support GPUs in addition to CPUs and memory and all the other things. And that was just about trivial for us to add support for. And so I think that, that kind of core intuition that wastefulness was causing people to repatriate. Wastefulness was, especially in an economic crunch like we're in now, causing huge amounts of heartburn in large organizations who are going, we've got to cut this down, and we have no patterns for cutting it down. How do we cut down the spend? How do we cut down the number of CPU instances? And we said, all right, that is a problem we can tackle. And as these last couple of years have borne out with the rise of AI, we're going, oh, so we just happened to stumble into a solution to a problem that's on the rise in an extreme sort of way with these $30+ an hour instances. So I think, it's dangerous to frame things out as being, overly focused on something on green computing, right? Because immediately you're attracting attention to something here that is difficult to quantify, that is, probably contentious in some circles at least. But really, at the end of the day, that is what we want, right? We want to be more efficient with the electricity we use, more efficient in our hardware, then we can cut down on our consumption of both of those things. And that's a win. It's much easier to talk about that in terms of cost and saying, we can cut down the cost of things. And that's definitely a very salient measure. But that's, behind the scenes, that really is why. It was that one conversation and hearing someone say, it is so frustrating to know that all these systems we're putting into production are sitting there at 80% idle. And that's something that I think, we've taken some big steps towards solving.
And how does Fermyon itself do this? Could you give us a bit about the details of how does Fermyon scale down quickly to almost zero if needed?
Yeah, so when we looked at that little demo there, we were running Spin and we ran it locally. And so what Spin was doing when I started it up locally was it was loading my WebAssembly component into a sort of development mode web server, right? That is just running there. It's delegating inbound requests to my serverless function. So take that same concept and say, okay, imagine we could run a gigantic version of Spin. We at one point toyed with calling it Mega Spin. We ended up calling it LHC. Mm-hmm. But LHC, which is the thing that's running inside of Fermyon Cloud, it is just basically a version of Spin that has that can run thousands of WebAssembly modules per instance, per process, right? And route inbound requests to the appropriate serverless handler. And so instead of having to allocate one VM per serverless function, which is the way the large clouds do it, we can basically multi-tenant thousands of different applications by potentially thousands of different customers all onto the same LHC instance, and then be able to execute these things, nearly instantly. And because the startup time for WebAssembly is about a millisecond, and because the average runtime of a serverless function goes from a few milliseconds to maybe a few minutes at the high end, we can very effectively time slice things up. Right. So we can then pack in lots of applications and be very optimistic about the fact that at any given time, even with 1,000 applications per instance, probably only a few dozen of them are actively at that millisecond handling a process. So we've discovered that we can actually drastically under provision most applications and say, yeah, you need this much RAM, yeah, we've got that, but your max, you're never going to hit peak workload for more than a few bits during the day, and even so, we can effectively time slice this very much. So even the current Fermyon Cloud, which has thousands and thousands of applications deployed on it, is done very modestly on just a handful. I think we're probably at about 8 VMs, and that includes all the redundant ones and everything else. And those are 2XL VMs. So very, very efficient compared to the comparable Kubernetes cluster that would easily be past 100 nodes by this point, right? It's all about achieving density by really just focusing on what is that compute unit people actually need. And this is, again, the difference between server and serverless, right? In the server world, you have to always have your server up and running. So it is always consuming resources, even if it's not handling any requests. In the serverless mode, we can say, you only have to be running your thing during the instant that you're handling a request. And likewise, if you get slammed with 10,000 requests, we can just spin up 10,000 simultaneous handlers and deal with all of those at the same time and shut them back down. We can even distribute them across multiple VMs, multiple LHC instances, and it doesn't break a sweat for Fermyon. And likewise, you're being very effective and efficient in the fact that you're really only being billed for those little blinks, those little instants where something is running, instead of having to keep something running that's always consuming CPU and consequently always running up the bill.
Yeah, sounds like a very practical approach. And last question I have for you, Matt, is about AI, and you kind of briefly touched on it in your responses just before this. When in your demo, you spoke about how if not for the default config, there'd be a series of question and answers, and that kind of reminds me of the ChatGPT experience.
Yeah.
And then you just now spoke about how you added support for GPUs, and you're realizing that Fermyon can really be used for AI workloads. Can you comment a bit about what's happening in AI today and how you see this impacting what Fermyon does and serverless, and how serverless could actually do something here that people may not think about serverless as a great place for running AI workloads, but why you would think so?
I think for me, the thing that has really hit, right, in the moment following ChatGPT's, instant rise to fame, right, the thing that really hit me was all developers are going to have to be able to do this in the not too distant future, right? Probably at this point now, right? So up until that point, I think I had assumed we would see a class of AI developers who would have PhDs in AI related fields, right? And now it's turning out that the full stack developer, the average full stack developer, the average microservice developer, the average front end and back end developers all need to understand and be able to use this technology. So if that's the case, then we as developer tool vendors, right, developer tool builders, open source community members, we need to figure out a good way to build tools that help the developers streamline that experience. And so for us, we're talking all the way through this talk about removing speed bumps from the road that the developer takes. We said, all right, well, we had already built database integration to make it super easy for you to have a database provisioned automatically for you locally, automatically in Fermyon Cloud. Same with key value storage. We said, okay, could we do that with AI? What would it look like? Well, the developer is going to want to have their model control their model. The developer is going to want to have a very easy API to work with, or the option to work with some of the existing APIs like LangChain. And the developer is going to want to not have to think about how they orchestrate all of that. And then at the end of the day, the developer is also not going to want to spend a lot of money on it. So we had this kind of checklist of features we needed to do that we thought were just going to be the normal criteria, right? This is what all developers are going to be clamoring for within the next few months. And so we set out to build basically an AI inferencing backend that would feel very similar to the other services we operated, where you could import that spin library, like we saw in the TypeScript demo, import the machine learning library in there and be able to instantly send some prompts over and get back a response, or even, use the existing Fermyon SQLite based database as a vector database and be able to store your tags in that, and then be able to use that to seed into the AI inferencing backend. So that was really our design goal and how we began to implement that. The existing version largely allows you to use the Llama 2 model. That's because we're in this kind of early beta period of it, the early kind of pre-release state. What we really want to enable people to do is to bring their own models. So they can train up a model, or they can choose their favorite model. They can upload it in here. They can test it locally, regardless of whether they've got a CPU or a GPU or whatever. They can test it locally. It might be slow locally, but when they deploy it to Fermyon Cloud, they can choose to use, like our A100s and things like that, and have a very high performance solution there. And again, just like we were talking about a moment ago, and being able to achieve this kind of high density usage by keeping lots of tenants on here and sort of time sharing very effectively the CPU usage, we can do the same on the GPU. And when we can time slice the GPU effectively like that, nobody's paying to run an A100 100% of the time, right? Everybody's paying just for their few milliseconds of access time, or their few seconds of access time while they're doing their inferencing. And that then enables us to produce a much more cost-effective version of AI. I think that this is a good approach, because I think that, this is just going to become part of the normal developer toolkit. And the easier we can make this, and the more power we can deliver to users with less friction, then I think the more users will find value about that. And the more, again, a lot of these ideas just are like, like, what do I want, right? As a developer, what do I want to be able to do? I don't want to have to think about standing up a service over here, provisioning some A100s, writing some kind of platform to queue things up and answer questions. I just want to be going as fast as possible and still be able to say in good conscience, right? I still own the data here. I'm not sending it out to somebody else. I still have an easy API and code that is manageable for me to write. And so that's been our goal, and that's why we introduced AI inferencing.
All right. All right. Wow. Fascinating discussion. I want to go back and listen to this one again slowly and yeah, just take it all in. There was just so much that we covered, so many topics, but just all really interesting. And I love just your explanations for so many of them, WebAssembly especially, and just so many other little tangents that we went off on. But as we wind up, before you go, I wanted to ask a couple of questions, Matt, to get to know you a bit. What would be your alternate career path if not for your job in tech?
So I actually set out originally to be a philosopher, for reals. So I have a PhD in philosophy. I thought I'd be a professor. The problem was philosophy moves at a slow pace, and I'm kind of a fast paced kind of person. But on those rough days, I like to imagine myself teaching a philosophy course, teaching Aristotle at a university or something like that. I mean, probably never going to happen, but alternate universe Matt would have been a philosophy professor.
All right. I can guess what all those books are behind you.
Yep, all those up there. Yep, all those over there. Yep.
Who's your favorite philosopher?
I spent a lot of time working on a philosopher named W.V.O. Quine, who did a lot of work in epistemology and in logic. I find some philosophers just kind of fun to read. They're even if I don't necessarily believe what they say. There's some like Deleuze and Guattari who are just way out there. Kierkegaard I find very enjoyable. But at the end of the day, I'm going to have to say Aristotle. For everything from day-to-day life to how I think about software development is influenced by Aristotle.
Yeah. I've dipped my toes in some of his works, read some of them, but yeah, I've got so much more to read. Good to know.
There's a reason why philosophy is a career, because you really can spend your entire life reading this stuff and still not mind the depths of it.
Yeah. It's good to see that you're still into it though. What would you say is one hobby or interest you picked up during the pandemic?
So shortly before the pandemic, my brothers coerced me into playing Dungeons and Dragons and had a great time. 2 days before the lockdown hit, I was at the hobby store trying to find something that I could do, knowing that I was going to be cooped up in the house for a long period of time. I made an impulse buy and bought a whole bunch of D&D minis, like little plastic minis, and a whole bunch of acrylic paint. And thought, I'll probably do this for a couple of weeks. And I started doing it and really actually enjoyed it. It's very therapeutic. I got my big, Coke bottle glasses and little tiny paint brushes and trying to paint eyes on, 38 millimeter scale models. But it's turned out to be just something that I enjoy. It allows me to kind of turn off the analytic brain and turn on the creative brain and while away a few hours. So while I thought it'd last a couple of weeks, I still do it now. It's been 3.5 years since I started that.
Yeah. I think a lot of us had this phase of doing things with our hands for a change and just being away from the screen. I think there was a good shift that happened.
I agree.
You kind of touched on this, but what was the moment that you knew you were going to be a programmer?
So the kind of funny story is I got hired as a teenager to work for the utility company in Colorado Springs. And I thought I was getting a job mowing the lawns, but when I got there on my first day, they sent me to the computer room and introduced me to a guy named Bob who, sat me down and started teaching me the fundamentals of programming. And I ended up doing web development there. Found out months later that it was an accident, that they hired two Matts. I was supposed to mow the lawn and the other Matt was supposed to do the programming thing. And he had a master's in ECE or something. And I was a high school student. I think I didn't originally think that was going to be my career, but it certainly was fun. and the analytic part of it appealed to my philosophy brain, right? And when I went through undergrad and then on into grad school doing formal logic and epistemology and metaphysics, at the same time I was seeing how software development was really an offshoot of that and a practical way of experimenting with it. But it wasn't until maybe just shortly before I finished my PhD that I started thinking, I find more joy in the software development than I do in the philosophy. So maybe I should invert the hobby career relationship here and write code for a living and do philosophy for a hobby. And that kind of was that moment when I made that switch.
Oh, yeah, that's a really neat switch.
Yeah.
Could you name one tech company that inspires you and why?
There are a lot of tech companies over my life that have inspired me. The surprising one for me, though, was early in my career, the enemy was clearly Microsoft, right? Early in my career, when Gates and Ballmer were so anti-open source and so anti-Linux and painted the picture of open source developers like me as the enemy and Linux as the virus. When Satya took over Microsoft and things really changed very quickly, I went from being a big detractor of Microsoft to really thinking, this is a company that now understands how much value can be brought by a community of developers. And so I went, in just a few short months from being very sour on Microsoft to being very keen on them. Even now, having left Microsoft now and gone off to start up my own company, there is a lot to admire about the way that organization has grown and shifted and matured and turned into a big company that is still a company that is very productivity oriented. So that's, I could name probably a half dozen other companies for one reason or another, but of all of them, it's been the biggest surprise and the one that these days I think has done the most number of things right for a large organization like that.
Yeah, quite a transformation. Talking about those days to now playing a part in creating WebAssembly and just so many of the other open source technologies. Really amazing.
Yeah.
The last question for you, what's something that you found out about being a CEO that you didn't know before you became one?
Now, if we're talking about long lists, that's a long list. I have been an extrovert. I'm an extrovert. You might have caught on to the fact that I'm a little bit extroverted, right? I think, largely thought of my extroversion as sort of a hurdle to overcome. Many introverts are going to find this very weird, right?
Yeah.
But when you are an extrovert in an introvert field, you're like, I don't know if I should talk to these people today, right? Everybody values their heads down quiet time. And likewise, meetings were strange for me because they were oddly cathartic, right? I liked being in meetings. I got a lot of value with collaborating with people, but I always was well cognizant of the fact that everybody else looked at these as a waste of time. When I took the CEO role and suddenly realized the greatest value I have is actually just to orchestrate all these other things, right? No more am I looked upon as a really good coder in Fermyon. We have an entire, 15, 16 engineers who are amazing engineers. I am not one of them. And I suddenly found that extroversion was a little more of my superpower, where I had originally kind of viewed it as a weakness. And consequently, I can come out of a day of going from a marketing meeting to a finance meeting to an operations meeting to an engineering meeting and feel exhilarated because I spent a lot of time extroverting and, did my best to create the floor upon which good decision making and quality thinking could occur. And at the same time, I don't feel like I'm burdening, the same development team with, 12 different back-to-back meetings. So that's been kind of a fun one to discover and actually learn to kind of lean into something that I previously viewed as sort of a weakness, or at least something I should try and withhold or hold back a little bit.
Wow, so fascinating. Because I know. In this, I'm an introvert, by the way, and and most people are in this space, as you mentioned, and so. It's funny to hear you say that you thought that was a weakness, being an extrovert, and it's great to see how you figured out how to kind of make the most of it, balanced out, and I think it's really cool. Just a lot to take away from that.
Yeah.
With that,
It
we
has,
come to
though,
the end of-
switching to the CEO role has been one of the biggest, hardest changes because there are just so many things to learn. And you just have to embrace the fact that you don't know most of these things. And you're going to do sort of a halfway job until you learn a little bit more and then you make the right hires. But definitely a long list.
Yeah, that's great. I'd love to have you back again to talk, like I said, about Helm and just to hear you more. I mean, it was a lot of fun chatting with you today. So thanks so much, Matt, for just sharing from all of your experiences and just telling us about Fermyon and just generally just inspiring us about just how you are and how you look at things. I think it's a really fascinating conversation. So thanks so much for spending this time with
Yeah,
us.
I had a fantastic time. Thank you very much for having me.
All right. And thank you to all of our viewers and listeners. We hope you loved listening to Matt today. Definitely go and check out Fermyon and connect with Matt if you'd like to get to know more about him and Fermyon and what they're up to. Do tune in again next week for the next episode, and we'll see you then. Have a great day. Bye-bye.